Hi, welcome to today's tutorial. We'll be talking about K-curve methodology for inventory management. So before properly introduce K-curve, we'll be talking about the base K-curve is built on, which is the EOQ model, or we can call it the economic order quantity. EOQ is first introduced by Ford Whitman Harris in the year 1913. EOQ is defined as the ideal order quantity a company should purchase to minimize the inventory costs, such as holding costs, shortage costs, and the ordering cost. On the right-hand side, we can see the formula of EOQ. The Q is equal to EOQ units, D equals to demands, S is equal to the ordering cost, and H is the holding cost. And the formula is where Q equals to the square root of 2 times D times S by H. And also the H holding cost can be calculated by multiplying the unit cost and the inventory holding rate. So the formula can be varies as this one, the one over here, but however, the one on the book shows a bit of error over here. The square root should be over here instead of here. Yep, so this will be the proper equation of EOQ. Next we'll be using graph to talk about EOQ. So first of all, we can see that EOQ is formulated by the total cost, holding cost, and the ordering cost. So these three costs is the costs we need to take into consideration to formulate EOQ. After that, EOQ is used in the graph figure 1, which is the EOQ relevance approach. So we can see over here this line is actually the economic order quantity where the demand is estimate, and when it reach this point, order will be placed, and the lead time will be used as like a buffering time for the business to like the buffering time for the supplier to send the item over to the business. However, EOQ has been neglected by a lot of practitioners because of these three reasons. First of all, the holding cost and the ordering cost is not easy to estimate. We can see in this graph, the holding cost and ordering cost plays a significant role in determining the EOQ. However, the instability of holding costs and ordering costs will affect EOQ by a lot, and time after time the EOQ will be not accurate, and the customer will not be dissatisfied. Sorry. And after that, we can see on the one on the right top side of the graph, we can see that the demand rate is constant, and which is not always the case. So the forecast of the actual accurate demand is close to impossible, where EOQ is not relevant. Sorry, it's not relevant. This constant demand is not relevant in this graph. And also, the immediate availability of product is required with supplier. If there is any changes of trend with certain goods and the supply is limited, EOQ system may be an issue. However, but if the company has many suppliers or good relationship with supplier, this disadvantage will be neglected. So for example, if the shop has only one supplier and the fluctuate of demand suddenly use up all of his product, and the supplier has there's no availability of the certain goods, the shop might be facing more cost and will lead to a loss in his business. Okay, so next we'll be talking about Pareto principle. So as we know, Pareto principle is known as the 80-20 rule, and it is widely used in inventory management as ABC analysis. So a product will be 20% of inventory, account to 80% of their total annual consumption. B product is medium inventory to 15% of total annual consumption, and C will be the minor inventory to 5% of the annual consumption. Next, sorry. The disadvantage of the Pareto is that, as we mentioned, Pareto only has three groups, which is A, B, and C. If a company has a lot of like SKUs, three groups is insufficient for them to um, segment the product. And the second one is the percentage is fixed into each classes regardless of the nature of each item. So basically, only the 80 and 20%, 80%, sorry, 20% of the inventory is fixed. So you can't really change the Pareto principle regarding to the percentage. And the last one would be the boundary of AB or BC item is chosen by the manager preference, no standardized. So in this one, we can see maybe the last item of A product. Some manager would like to include it into the B, or they would like to include it as A, or like B item, the last item of B. Some manager would like to include those item into C, and maybe some manager would include those item into B. So here, so the K curve is introduced by Sharp Butcher and Ralph, and the K curve methodology is based on EOQ model and Pareto principle. And EOQ is dismissed by a lot of practitioners because, as we mentioned earlier, the ordering and inventory holding cost. Also, there's three steps of uh, uh, creating a K curve. The first one will be expressing EOQ as EOP. The second one will be creating a bridge between EOP and Pareto principle. And the last one will be the variation of K to create an exchange curve. Okay, so let's have a look at the first step. So the K is introduced into the equation um, of the EOQ equation. So K will be substitute 2C by I. And I'm gonna show you in Excel file to how to actually create EO create a relation between EOQ and EOP. Okay. First of all, we can see this is the basic information we need to sorry we need to perform a K curve. So this will be as the SKUs of the product. In this case, we have around 200 products. And also, there'll be the annual usage demand, the cost per part, and annual spend. So to create EOQ value, as you can see, I've prepared here. So the EOQ value is the square root of the constant k, which mentioned earlier to replace the 2c by I. So here's the constant k times C5. Okay, we need to times the annual usage demand and also times the cost per part. So we'll get this number. So in order to drag it down, we need to freeze the constant k, or else Excel will program by using B2 instead of B1. So in this equation, we can see that the B1 is frozen times C5 divided by D5, which is times the annual usage of demand and divided by the cost. And we'll get EOQ, and we just need to drag it down. As for the EOP, we need to find out how many working days is there in a year. So the standard working days of in a year is 250. So we'll use the working days, times the square root of the constant k, which is 30, and divide by the annual span, and we'll get this number. So in order to drag it down, we need to freeze these two cells, the constant k and working days. Okay, next we'll be talking about step 2. Step 2 is building a bridge between the EOP we calculated just now and the Pareto principle. So first of all, we need to create two information in this step. The first one will be creating the value class, and we need to decide the cycle days based on the value class. I'm sorry, I think it's the other way around. We need to decide the value. Sorry. Oh yeah, we need to decide the value class based on the cycle day over here. So the cycle day for me, I'll give the multiply of 5. So you might be questioning like why doesn't it have like 320? Because the cycle days has exceeded the working days, which make no sense. So over here I've created 6 value class, and the limit for the class limit I'll be dividing into two parts, and we need to put, okay, the first part will be if formula. So basically why I use the if formula is because um when a class limit is until the last one, we can't use we can't use 0 into Excel. Like anything divided by 0 equals to they'll show error. So let's say if I take away this if formula, we'll see that it will show error. So if I use the if formula, it will just show a dash, which makes the table looks more complete. And the second part we'll be talking about is the whole equation of class limit. So first we need to use the working days time itself, so it will be 250 times 250, and we need to times the constant k, which is 30, and divided by the 2 cycle days we chosen, so should be 5 and 10. So the first one is calculated, and we just need to drag down. So sorry. So when the last one is complete, like we can't use 160 times 0, so you just show error. So over here I use this if formula so that the class limit wouldn't show error. Okay, so how do we put all these numbers into the value class? So this is a very tricky part. As you can see here, it's a really complicated formula, but I'll explain it to you for one step by one step. Okay, first of all, we need to determine the annual spend value. So if the annual spend value is greater than the class limit, it'll show 1. So then if it's greater than the class limit 2, it show 2. So we do it for another like 6 step. uh like if it's greater than this number, it will show 3. And so in this case, because it is 6, the annual spend value is really small, so it falls into value class of 6, and the cycle day will be determined by using the value class over here. So if the value class is 6, which means that the cycle days will be 160. There you go over here. So the formula of this is pretty easy as well. We use the choose formula over here. So we go with H5, which is this. If this is 6, it will show 160. If this is 5, it will show 80. So in order to drag it down, this is the tricky part. We need to freeze the one over here. We need to freeze, maybe we use like, okay, for example, E6. If we want to use like 210, we won't be like calculating for all 200 SKU. We'll be dragging down. So we need to freeze certain cell. So in this one, we need to freeze the cell we take from this number, or else Excel will just drag down. Like maybe for the second one, he'll just use this cell. For the third one, he'll use this cell, which create error. So we need to freeze the cell we use over here. And there you go. We have the value class and the cycle days. Next, we'll be looking at how to properly create this K curve. So as we can see, here's the pen. So we can see the curve should be looking like this. So it's we'll say as a descending curve. As we can see, the greater the K, the K100 is here, the lower the average inventory. I'm sorry, I couldn't see well, but this is average inventory. In another way, the lower the K is the greater of inventory, but the lesser the order. So I'll teach you guys how to create this curve and what kind of data will be need in order to create this curve. Okay, first of all, we can see that I'm using the multiply of 10. So we'll be having K equals 1, 10, 20, 30, etc. until 100. Okay, so here's how to create. Okay, with the help of Excel, I would say it's pretty convenient to create the K curve. Okay, from here, we will be creating all the basic formula of value class of the cycle days, EOQ and EOP. So from the start, we only have this much of information. And then the second step, I have created the EOQ by using the formula, EOP by using the formula times the working days, and the value class table, which is this. So we call this, it's like a, what do you call that? It's like, maybe it's like, we are creating we'll be creating a constraint over here to decide which of the annual spending will go to which class, and determined by the value class, we'll be seeing like how many cycle days we need for each item. Okay, so the next step, The first will be using k equal to 1. So we can see here we have two new column. So first of all, we'll be needing the number of orders. So the number of orders is pretty easy to calculate. We just need to use the working days times the cycle days. So okay, you can see like the cycle days over here we can use. Sorry, it's calculate to determine the number of orders. So for the first item, the number of working day is 250, and the cycle days is 160. So we can see that this item is very minor and not significant. So the number of the throughout the year is only like one times or two times, something like that. And we just drag it down. Yeah, so we need to remember to freeze this working day in order to drag it down, or else the Excel will be programming maybe the second one he used B3, so remember to freeze this cell. Second, we'll be talking about average inventory. Okay, the average inventory is pretty simple and straightforward. The formula will be using 0.5 times the cycle days times the annual spend value. So for this first item, it's because it's really not significant. So the average inventory for this item is only like 0.000576, which is pretty low. And we need to just drag it down all the way just to create drag it down all the way for the other 200 item to create the whole table for average inventory. So over here we can see that we has used 10 like 10 different type of k. So we have like k1, k equals to 10, 20, sorry, 30, 40, 50, 60, 70, 80, 90, and 100. So different type of k will be having so the benefits of having different of k, we can see that each cycle days is different. So the k, if the k is 100, the cycle days and the number of order, sorry, sorry, it's a mistake. So the different type of k define the class limit. So over here, if the k is equal to 100, the class limit will be 125,000, 250, and for the k equal to 100, it will become lower because of the k, and will keep on until like from 1 to 100. So okay, so you'll be asking me, why are we using so many k, to create a k curve? So the final thing, in order to create this k curve, we need the number of orders and the total average inventory. So we can see it over here. The different type of k will affect the average inventory, and also sorry, and also the total of number of orders. So these two is very significant to create a k curve. So at the end, we will be using the sum formula to sum out the 200 item of each of this k over here. Like we just need to sum everything, sum out, and we get all this number. Yes, you can see we're using the sum formula here. And to create k curve, first we need a table of data. So the first one, very straightforward, the value of k. We have 100, 1 to 100. The second one, will be the total number of orders. So for the K one, we'll be having, let's see, number of orders J all the way down. We'll be saving to 7,239.0625. So in this one, I've switched it to only two decimal because I reckon too many decimals is very it's very messy. And then we'll just do it for the rest of the value of k. So as we can see, there's a pattern going on here. As we can see here, the lower the number of orders, we get a higher of total average inventory. So this, if you want to see if you are right or not, in the final table data, we can use we can see like if the value of k is small and we get a big number of orders and we get a small number of the total average inventory. So in order to check if you are right, like if you are close to getting the curve over here, you can see that so the relationship between the k number of orders and total average inventory means the smaller the value of k, the higher of number of orders, and we can get a smaller total average revenue. So if we use the graph data of this, we can create this curve, which is pretty easy. We just use the insert. We just need to use this graph function to create this graph. Okay, so first of all, we can see that if k equals to 1, everything is plotted here. And as a manager, we'll be seeing that so which k we'll be using in order to optimize our inventory level and also our budget in the warehouse. Okay, back to the PowerPoint. Okay, that's all for today for you, how to create a K curve. And the last slide, I'm going to share to you what we have covered today. So as mentioned, K curve covers the weakness exposed by the EOQ model and Pareto principle. If you can recall, EOQ take a lot of consideration with only one holding cost and only one ordering cost, which is not easy to estimate for all of the product. Depends on your number of order, the quantity you order, and also depends on the supplier. And sorry, over here, the K curve has from K equal to 1 to a K equals to 100. So we have put 10 different types of K into consideration and to cover up the EOQ model's weaknesses. And also we have for this one is this. For the Pareto principle, which is only have 3 class, but in the K curve we have 6 different class to classify all the item and SKUs. And this is a pretty simple technique to set class limit and allocate item because Excel programs help us a lot. And the last one, the order frequencies can be chosen widely. So okay, in this case we use Kathmandu as we use Kmart as our example. So in the winter, heater, we need to order a lot of heater to supply we need to order a lot of heater for our customer. So the order frequency will be very high. But in the summer, heater will not be used for everyone. So the order frequency will be low. So in the K-curve, we can just change it really easily over here. All right, that's all for today. Thank you.